Hi class. So in this video we're going to talk about a topic called enumerations. And I think once again, I think the best way of describing this is to do it in the context of an example. Okay, so I'm going to pull up some code here. And here I have our first enumeration that we're going to show as an example. We're declare it using enum, okay? And here what we're seeing is a bunch of days of the week, okay? And what we're really trying to do is to provide descriptive names to, in this case, like a finite set of items that belong together. So I think days of the week provides a pretty good example of doing just that. So we're kind of bundling these this finite set of together. And this allows us to do is to define, when we're using this type def again, we're defining a data type that we're calling day, and day is restricted. Okay, day is restricted that it can only be a finite number of different possible days. Okay, if you're outside of those 7 days, you've made up a name that doesn't exist. Okay, so for instance, I can create a day, type day. I can give it a name. Okay, there's nothing preventing me from using a common convention is to use the capital D to indicate the data type and just like I did here, and then the lowercase to be the variable name. It's often done, and I can make a data type, and I can actually set that equal to one of those 7 possibilities. Okay, and that allows me to do certain things, right? Like I could say, hey, is it a weekend, right? Is day equal to Saturday or Sunday? Okay. So I can check, like say, is it the weekend? Else, it's a weekday. Or here we'll do weekday, it'll be an unhappy face, okay? Versus smiley face. Okay, so we could do things like that, right? So in this case, obviously, the logic is super simple. It's gonna say, hey, it's a weekday, so we get super sad face. Okay, so we can do that, right? If I change this as you would expect, like if it's a Saturday, if I spelled it correctly, then we'll see how it changes appropriately when we run it. Okay, and the value of doing this is oftentimes you're using some data, and the data would be easier for the programming logic to restrict the data type that it could to only be valid members of a finite number of elements in a set. So, like for instance, like I'm trying to think of a creative name for a day that's wrong. Like what if I did like one day? I combined Wednesday and Monday, right? Notice you can see the compile error is already showing up, right? Error, one days, undeclared. Okay, so it actually gave me a very helpful message. It even said, "Did you mean Monday?" Okay, so the reason I show you that is that by defining the data type here as an enum, it has to be one of these elements, right? One of these elements in the set. Okay, so it prevents you from making stupid mistakes and using something incorrectly. It also makes the code a lot more readable because we can compare things to other items in the set to see if it's equal to something. Okay, now I want to point something out, that in reality what's going on here is that that internally each one of these numbers, this is actually where the term enumeration comes from, are stored internally as a number starting at 0. So Monday actually is going to be stored inside your computer, right? As Monday is going to be the value 0, Tuesday 1, 2, 3, 4, 5, and 6. So I want to show you something here. So like if I initialize this to Monday, right? Day is Monday, and then I put it here to print it out as an integer in base 10, okay? If I go ahead and run that, okay, Notice it printed the day as 0, right? If I change this to something like Thursday, right? Notice it says the day is 3, 0, 1, 2, 3. That's where enumeration comes in. We're counting up, we're enumerating so that each one of these elements of the set have a unique number. Okay, so that's effectively, I point that out because that's how things are being stored internally, and that's a useful thing to remember. So these are effectively treated as numbers, and it would do the exact same thing here, right? Since it's starting at 0, instead of Saturday and Sunday, if I wanted to, I could do 0, 1, 2, 3, 4, 5, or 6. So if I said day equals 5 or 6, okay, that would also work just the same way. Okay. However, right, we want our code. Our goal is to write code that the logic is easy to follow. It's easy to edit and extend and modify, and it's a lot easier to use descriptive names like this rather than trying to keep track of all those numbers. All right, so there's a code readability issue, and we want to keep things really well organized. Okay, so similarly, I could do something like if I wanted to see if it's a weekday or a weekend, I could always say day is greater than or equal to 5, right? Would be a weekend, right? 0, 1, 2, 3, 4. 5 is Saturday, 6 is Sunday. So I happen to lay out the days this way. You could, if you changed up the order here, right? If I put Sunday first, it's going to change which number goes where. Okay. All right. So these come up a lot, right? We could imagine we could do something similar to this, right? We saw in a previous example building a student structure, right, which I have here. We've got a student structure. We've defined a type for that. And we did some like example where we ran through and said, hey, initialize a student and find the top student. Maybe you wanted to have we want to keep track of like a class year here. Right? So I could build a data type that defines class year, right? And what would make sense to once again to do that is to define an enumeration, okay, where I define all the freshmen, sophomore, junior, and senior year, right? However we want to write them here. And we could then we got to say class year, okay? We could see that in that case, I could use that, and I could use anything from members of this set to go ahead and initialize that or store that, right? So this way we don't have any years that are outside of that list, right? Would be restricted to items that are contained within that finite set. Okay, so we would have to change some of the other logic down here in terms of like if we wanted to change make student, right, so that we're initializing it properly, we could say, hey, class year s dot year equals year, right? So notice how much like we're defining these types, how much more extendable it makes the code, right? And we could be doing things down here like junior, senior, okay. Oh, I think I have a capital letter issue. Kind of wrote it somewhat quick, but we should really be consistent with how we are writing things. Okay. And so I can initialize the each student, right, the same way. So really what we're getting here, now we're combining some things. We've built a student data type, and as part of that, it also contains another custom data type, this enumeration we've done that takes care, that is representing of the class year. All right, so one other note to just point out is these enumerations, where I personally have seen them the most come up in my programming experience. And right now, by the date of this video being filmed, I'm teaching the hardware software interface class where we do some embedded systems as part of that class. effectively using microcontrollers, where you may have seen like Arduinos in the past. We use a different type of microcontroller, but the same kind of general concept. And enumerations are a really common way of keeping track of the state of the system. We look at, as part of that, these different system states that things could be in, such as like if you looked at a simple example of controlling a traffic light, right? There's 3 different states. The red light's on, yellow, or green. And you can use enumerations to keep track of which state you're currently in as part of the programming logic. So in my opinion, that's where I personally have seen it the most, and where you're very likely to see it used pretty heavily as part of your programming career,